Assalamualaikum student, this is the demo video for second exercises. Okay, so for exercise 2 is the production of cumin. So you have feed benzene and propylene entering a reactor produce cumin or isopropyl benzene, and they also give you 90% conversion. Here, this is a stoichiometry reactor because they give you a stoichiometry ratio. Then the product from the reactor go pass through a heat exchanger, a cooler, okay, and then separated. Some got recycled and the others go to product stream. Okay, so here the exercise already mentioned that you need to use the RK-Soft property method. I have put drag and drop all the necessary equipment that involved with this exercise. So you have reactor, heat exchanger, and also separator, and then put down all the material strip and label them properly. Okay, next step is to fill in the component ID. Go to properties and you pop out this system will pop up with this specification of components. So find, click find. So first you have benzene. Okay, click find now. Instead of just put benzene or propylene, so I suggest to put every component lah. So in this question you have three, benzene, propylene, and also cumin. So put all these three component. Compound, okay. So add. Next is propylene. Fine. Okay. And last one is cumin. Let's see if they have cumin. If they don't have, you need to put isopropyl benzene. Okay, good. They do have isopropyl benzene, cumin as. Okay, click add. Add. So you have all these three components. Okay, next step is go to method and choose RK-Soft. RK-Soft. Okay, here it is. Right, so it's blue tick now, so you can go to your simulation tab again. Alright, now you need to define the component in each stream. So for your feed stream you have 220 Fahrenheit, and 36 PSIE. So just lagging here. 6. Okay, then mole, total mole flow rate is in pound mole per hour. Go back to our question. So you have 40 pound mole per hour, and also propylene 40. So they are equimolar. 40. Okay, isopropyl you can put it 0, or you can just leave it blank. Right. Okay, feed stream settle. Then we go to the reactor. Okay, temperature is, let's see. Oh, they give you Q and pressure drop. Q is duty. 0. Okay, BTU per hour, and then pressure drop. Okay, you don't have a pressure drop here. Okay, you don't have pressure drop, it's only pressure and temperature. So pressure, zero pressure drop means the it should be the same as your initial pressure. So we choose the feed stream of 36 psi. So no pressure drop, zero pressure drop means same as the input. Okay, then you need to click on the reactions here. Click on new. So first, you need to make sure that your stoichiometry ratio is balanced. And here you only have one reaction. So you can put here reaction number 1. So if you have another one, then you need to add in another reaction. So this is reaction. We have one reaction only. So we have benzene and propylene. Okay. So the coefficient is for reactant -1. Okay. -1, it follows the stoichiometry ratio. So one benzene react with one propylene and it produces one cumin. And reactant negative. If you forget to put negative, it's okay because the Aspen is smart enough. Okay, let's see, click enter. They automatically put negative here because it's reactant. Okay, but you must make sure that your equation is balanced at the first place. Okay, and here you have cumin. Okay, coefficient is 1. Okay, and they also give us one more information, which is 90% conversion of propylene, if I'm not mistaken. Yes, 90% conversion of component here is propylene. Okay, then click next. Okay, so you only have one reaction. So if you want to add one more reaction, click new. So it will be reaction number 2 lah. Okay, so we don't have. So close. Can we delete this? Okay, delete. Alright. So reactor settle. And we go to the cooler. What was the information given? 130 Fahrenheit, pressure drop 0.1 psi. 130 Fahrenheit, pressure drop. Okay, 0.1, right? And next is separator, 1 atm Q0. Okay. DT 0 BTU per hour. Where is it? Okay. Alright. So if you see here, everything is blue. Okay. Required input is complete down here. So this is just status. So you can click end here, or you can run. Okay. Just click end. See if there is anything. Okay. So it's here. All the input is complete. You can run the simulation now or enter more input. So run the simulation now. Okay. So the Aspen will show this control panel. So here it says no warning were issued during input translation, no error or warning issued during simulation. So it's good. So you have your results. So you can go to now. So here result summary. Okay, and go to stream. So from here you can see what is your molar fraction, what is the temperature for each stream that you defined earlier, and you can change the units here. Okay. Let's say you want it to be in power per hour. Okay, so you have all this information. Okay, so from here you see the breakdown for each compound. Okay, so and okay, go to home. You can generate the report. Okay, for all. You can copy this later and submit. Okay, right. So that's all. Thank you for exercise 2. So we are done for exercise 2.